While I don't print really large parts all that often, one of the most common requests I see is for bigger machines. Because of that, I don't review large format printers often, and when I do, it has to offer more than just being big. Late last year, Qidi reached out to see if I was interested in testing their soon-to-be launched Max4. I had a largely positive experience with the Q2. In a lot of ways, this just looked like the big sibling to that printer, so I agreed to take a look. Well, I've now had this machine for a few months, which has given me enough time to throw a wide variety of prints at it and to get an overall sense of what it's capable of. In this video, we'll dive into the Max4, cover the specs, talk about setup, go over print performance, and I'll share my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. Let's start by diving into the specs. The Qidi Max4 is a fully enclosed corexy 3D printer with a build volume of 390 by 390 by 340 millimeters. The overall footprint comes in at 558 by 578 by 612 millimeters, not including the additional 500 millimeters of height that you'll need for the Qidi Box if you go with the combo. It also weighs 40 kilograms on its own, so it is definitely a team lift. The printer is made up of large plastic panels, a steel frame, plenty of injection molded connecting pieces, and a large CNC'd aluminum plate that's used to connect the two Z motors. Both the front door and top panel are made of glass, and I am a big fan of how they've got the hinges set up for that front door that allows you to swing it all the way open more than 180 degrees. For motion, the X-axis rides back and forth on a linear rail, and for the Y-axis, it uses 12mm smooth rods and bearings. The belts used for the corexy kinematics are large 10mm belts. For the Z-axis, the bed also rides up and down on those same 12mm rods, and it's driven by two stepper motors using lead screws that have their own independent drivers, which does allow the bed to be trammed from left to right. The toolhead on the Max4 resembles the one on the Q2, but there are some differences. On the left side is a filament cutter, which is used for multicolor printing or when unloading filament from the toolhead. The front cover is held in place with magnets and pegs, so pulling it forward and lifting it off gives you access to the hardware underneath. This printer ships with a pretty beefy heater on the hot end, capable of getting the included bimetal nozzle up to 370 Celsius. When I reviewed the Q2, I mentioned I did not see any load cells underneath the bed or the build platform, so I wasn't exactly sure where the sensor was. Well, thanks to a comment in that video and me confirming on my own, the load cell, which is what this printer also uses, is actually built into the heatsink of the hot end. Towards the right side of the heatsink is the hot end fan, and above that we have our extruder. Today's video is brought to you by PCBWay. With over a decade of experience, PCBWay offers high-quality PCB prototyping and fabrication solutions. Along with PCBs, they also provide CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I've used PCBWay for a range of projects over the years, including small batches of PCBs, plus CNC and SLM parts for custom printer builds. I've always been really impressed with their quality and super fast turnaround times. If you're working on your own project but need some help bringing it to life, check out the link in the description below to see everything PCBWay has to offer, and to get $5 off your first order today. There's quite a bit going on here that I think is worth pointing out. As far as the extruder itself goes, it looks pretty standard to what I've seen on the last 1 or 2 generations of Qidi printers, which is a large dual gear direct drive extruder. However, one thing that is very different is the tube that is going from the extruder that is routed up to the top of the toolhead. This is for an optional upgrade to the Max4 called the Polar Cooler. The Polar Cooler is a device that sits next to the printer that blows cool air directly onto the extruder, which cools that entire area with the purpose of preventing heat creep. The example I saw from Qidi is that you could use that to print with PLA in a heated enclosure to prevent warping on a really large part, and that polar cooler would prevent any sort of clogs or jams due to the PLA softening before being extruded. Personally, with a clean bed and proper first layer, I haven't really had issues with PLA warping, even on large prints, in years. That being said, I do think it would be really interesting to print PLA with the heated chamber and the polar cooler versus just regular open, and see how the tensile strength differs between those two print scenarios. Above the extruder is an inline filament runout sensor, and mounted low on the toolhead is a blower fan used for part cooling. For additional cooling, the Max4 also has a dual auxiliary fan setup on the left side that's used to blow cool air across the build plate. The bed maxes out at 120 Celsius and uses a magnetic flex plate system with an included dual-sided powder-coated PEI sheet. There's alignment tabs on the back corners to help with reinstalling the bed, and underneath the front of the bed is an LED status bar. Towards the back left of the printer is the built-in chamber heater, which is capable of getting the internal chamber temperature up to 65 Celsius. On the right side is a combo filter. Behind that there is a exhaust fan that's capable of pulling air through the filter and exhausting it outside of the machine when enabled. Moving a little higher up on the back, we have the poop chute and nozzle cleaning area. This uses a combination of a PTFE wiper as well as a soft brush for cleaning the nozzle. There's also a latch with a bit of soft rubber on top of it that the toolhead hits to open the chute and eject any purged filament out the backside of the printer. Other things worth pointing out inside the machine include a fairly large front light bar for illuminating the work area, a camera on the left side for monitoring your prints, and something that we don't see all that often, which is that the X and Y steppers are actually closed loop steppers. I know there are a few other machines using them as well, but I would certainly say it is still not the norm. Interfacing with the Max4 is done using a 5-inch touchscreen found on the top front left of the printer. The default view has the screen facing directly outward, but it can be tilted upward if you have the machine on the ground or some sort of a lower rack. The only thing I wasn't a fan of is the length of the screen's ribbon cable. When I tilt the screen all the way up, you could actually hear that ribbon cable rubbing, and I just wish there was at least a bit more slack. It didn't cause any issues in my testing, but I still feel like that is a place where there is some room for improvement. Also, on the top left of the printer is a full-sized USB port if you want to print locally and not over your network. Both of the side panels have an acrylic window for peering into the printer. There's also hand slots or cutouts that give you a place to grab from when moving the machine. The power input as well as on-off rocker switch is not on the back of the machine, which I'm thinking might be due to how difficult it could be to reach the back of the machine, depending on where you have this thing located. It's actually on the bottom of the right side of the printer. At the back of the printer, there's 2 access points for adjusting the belt tension, a few connectors, the poop chute, an electronics fan, and an additional vent used for exhausting air from the chamber. There's also an Ethernet port located at the bottom if you prefer to have a wired connection. One thing I was really curious about was to see what the electronics look like, so I removed all the screws on the back panel so that we could take a peek underneath. Back here, you'll find a 24-volt PSU, an SSR, the rear side of the chamber heater fan along with the exhaust fan, and the primary controller. The controller, labeled X123V1.0.1, is relatively small, which is due to the fact that there is a secondary toolhead board. The X and Y motor ports along with the drivers aren't even populated, which I assume is because the closed loop motors have that functionality built in. For cable management, they're just using a few cable raceways, and while nothing stood out as problematic, I do feel like they could have done a nicer job with the overall planning and wire management. The Qidi Max4 came packaged nicely, and the longest part of the initial setup process is just removing all of the installed shipping screws. For the combo version, there are 2 at the front holding the Qidi Box in place, 4 securing the Qidi Box bracket to the frame, 1 at the top, and another 4 holding the bed down. Outside of that, you're mostly cutting a couple of zip ties, removing the packaging material, and then either installing the single spool holder or the Qidi Box. If you didn't catch my video on the Q2, we did a deep dive into the Qidi Box, so I'll have that linked in the description. In summary, the Qidi Box is Qidi's multi-color, multi-spool management filament dryer, and a little bit later in the video we'll cover some of sort of the high points, but for a more detailed breakdown, I highly recommend checking out that video. On first boot, the screen guides you through the initial setup process. This includes setting a language, choosing your region, optionally connecting it to your local network, and then pairing it with the Qidi Maker app, and then walking you through the entire unpacking process if you haven't already completed it. The final step is the self-check as well as the initial printer calibration. This starts by homing the machine and then verifying that the heaters and thermistors are working correctly and that all of the fans are turning on and are responsive. After the self-check completes, it runs input shaping for X and Y, trams the bed from left to right, and then performs a full bed mesh calibration. I didn't time the full bed mesh, but if I had to guess, it was somewhere around 10 to 15 minutes. When the massive box for this printer showed up, I quickly discovered that the initial area I'd planned on testing this printer in my garage just wasn't going to work. So this printer sat for about a month while I was waiting for a bigger space up here to clear so I could begin my testing. During that time, I was informed by Qidi that they were working on some big firmware updates to address some early issues. So the first thing I did once I got this printer unboxed, set up, and calibrated was update the firmware to the latest version. Once completed, I was ready to fire off a test print, so I took a look at the pre-sliced files that came on the printer. Nothing really stood out to me and I just wanted to run a quick print, so I went with the Benchy file. Even though we had just ran an entire full bed mesh, I quickly discovered that this printer uses variable meshing as long as it is enabled in the slicer. The Benchy turned out alright, but not amazing. Even though I had the front door open to ensure that air was able to leave the printer since we were printing with PLA, there was noticeable stringing, some sagging on the very top of the part, and I even saw that there was some inconsistencies in just the outer walls. To rule out any possible fluke that may have occurred, I ran the exact same print again, and the results were identical. Since I had no idea how this model had been sliced and I was using my own material, I decided at this point I would just jump over and start slicing up files of my own. With that, I want to quickly touch on the firmware and slicing for the Max4. As for the firmware, this printer is running Clipper. If you go to the web interface or the device tab, you can see a very familiar fluid dashboard. The only thing I don't know is if there is a bit of custom code around the Qidi Box to make that play nicely with the dashboard, but it is fluid and Clipper. At the time of recording, I didn't see any of the source code available for the Clipper firmware. However, I did confirm that you do have SSH access using the username Qidi and the password QidiTech. As for the slicer, Qidi recommends using their Qidi Studio Slicer, which is a fork of Bamboo Studio. That's the slicer I use for all of the files we'll be taking a look at in this video, but I did confirm that the latest version of Orca Slicer also supports the Max4, and with the latest update, you actually have the ability to sync filaments from the Qidi Box directly into the slicer, which is awesome. From there, I fired off a handful of PLA prints. I started with a Dragon Egg Twist Fidget model. I'd seen this articulated model before, and after the Benchy, I really just wanted to see what the surface finish was going to look like and how it did with the tolerances of all the sliding pieces. I was really happy with how this turned out. The moving pieces took a little bit of effort to get going, but overall, both the surface finish as well as the sliding of the print-in-place parts, I think the Max4 did a great job on. Next, I moved on to a Brachiosaurus Kit Card. This isn't a very tall model, but it does take up a fair amount of the build plate, and I thought it would be a great test to see just how consistent the first layer is or is not across the build plate. Well, other than just a few fine hairs, the print turned out nearly flawless, and the bottom layer is consistent across all four corners. Aaron requested a bookmark for Jackson, so I found a Pikachu Q2 4-colored model that I sent off and printed out next. This was really a quick print with only 5 color swaps, but I was really happy with how the finished part turned out. After that, I printed out a Mario themed piggy bank. The end result is in 2 colors, but the parts actually print in just single colors and then are attached to each other once all of the prints have completed. With the large yellow cube, there was some slight inconsistencies in the walls that I believe can be addressed via slicer settings, but overall I still think that the finished part turned out solid. The one issue I ran into and sort of had been running into that I addressed in just a moment was things sticking too hard to the build plate. The thing that was throwing me off is that normally when a nozzle is too close to the build plate, you get a bit of an elephant's foot, which is just a wider, bulgy first layer or two. And that was not happening, but the little purge line that this printer was doing before starting each print was like just permanently attaching itself to the build plate. I wasn't able to scrape it off, and in a couple of cases, like on the top of the Mario cube, you could actually see that it just embedded itself into the next printed part. Around 8 years ago, I printed out a large Lighthouse model for my mom that she still has to this day. So when I found sort of a newer multicolor version of it, I knew that I had to make her another one. Technically, the way that the multicolor is set up on this, you can get away with a dual color printer. There's a plate of black and white parts, a plate of black and gray parts, and the final plate does have white, clear, and black and clear, so you could split that one up. I ended up just running this as 3 different trays of parts. Most of the parts turned out great, with the exception of the really detailed piece towards the top. This had quite a bit of stringing, and some of the vertical pillars just didn't connect or print correctly. In the Max4's defense, it is a very tiny detail to print, but I do feel confident that I could get better results on a different printer. My theory is that even though I have the door all the way open for these PLA test prints, the large bed heater is just generating enough heat to cause the PLA to become slightly stringy. If I didn't have the Qidi box sitting on top of here, I'd probably also remove the top panel to let even more airflow through the printer and play around with dropping down the printing temperatures ever so slightly. This was also the final print for me until I did something about the adhesion that had been too strong. When I removed a couple of the top pieces, the supports stuck down to the bed and didn't come off, and it took a ton of effort and scraping to try to get the parts off without damaging the PEI, which I couldn't even get them off fully. So as sort of a last ditch effort, I ended up running a small couple millimeter cube test print on top of the areas where there was still filament stuck to the build plate, and I'm very proud of how it worked. You can see actually the filament on here that this was able to pull off, but it basically stuck to the PLA I printed down, and I was able to remove it all without having to scrape any more on that PEI. After this print, I raised the nozzle, I think 0.075, if I'm not mistaken, and that basically solved this. I still had great adhesion moving forward, but not to the point where I was struggling to try to get parts off. Next, it was time to move on to some ABS and ASA printing. A lot of times when I'm testing out printers and doing ABS or ASA parts, I'm printing out either printer build pieces or different mods, but in the case of the Max4, I knew I had to do something bigger. While searching around trying to find something practical, I found this modular shoe rack, which I felt would be a perfect test for the Max4. These are large parts, and normally when printing with ABS or ASA, that would mean warping. But thanks to the Max4's built-in chamber heater, I had 0 warping across the 6 large pieces that I printed out for this shoe rack. I did, however, run into some very rough walls on those prints. The artifacts formed around the 3 openings in the side of the parts and seemed to sort of ripple out from there. It looks a little more dramatic on camera just because of the way the lighting's coming down and the colors that I printed these parts in, but it's definitely disappointing considering the extremely positive experience I had on the Plus 4 printing out large ABS and ASA parts. At one point between the trays of parts, I played around with swapping the wall order, but didn't really notice any difference in the result. Since the inconsistent layer stacking doesn't appear to be at random and is really largely isolated around the openings in the parts, my theory is that it's not a hardware thing and it's just that the profile is pushing this machine at least for this print, this profile, a bit too hard. If I were dialing in a better profile, I would start with backing off on the max flow rate, as well as just slowing down my speeds and accelerations. After the large shoe rack, I moved on to PETG. I made sure to dry both spools overnight to remove any possibility of moisture being an issue. I printed out a large bubble wand and tray for my son, as well as a pretty cool Hot Wheel car display rack. I was really happy with the results on both of these, and the Max4 did a great job with PETG. For the Hot Wheel logo, I did turn that into a multicolor print by doing some filament painting in the slicer, and I did print that out of PLA instead of PETG, specifically because I didn't have the right colors in PETG. The last filament I wanted to throw at the Max4 was some TPU. I had a positive experience printing flexibles on the Q2, so I didn't anticipate any issues with that here, but still just wanted to be sure. For this test, I used some 95A TPU on the spool holder and fed it through the guide tube into the toolhead. I printed out a handful of these cable ties, and as expected, the extrusion was consistent. If you plan on printing TPU much softer than 95A on this machine, I would recommend looking into a setup that allows you to top mount the spool and shorten the path between the spool and the toolhead as much as possible. One last thing I want to touch on is the Qidi Box. As mentioned earlier, if you want to see a bit more of a full deep dive, check out the link to the Q2 review in the description. But I do want to cover some of the key points here. The Qidi Box allows printing with up to 4 colors in the same print, or you can load up to 4 commonly used spools, so you can easily choose between them while slicing. It also has a built-in filament dryer capable of reaching 65 Celsius that can be ran while printing, supports abrasive filaments, and continuous printing functionality. Overall, from the testing I've done with it, the filament swapping process works, and it's proven itself to be quite reliable. The biggest downsides is that this is by far the noisiest multi-color filament swapping system that I've used. When it's fully loading in a new spool or doing a swap, the sound it makes reminds me of when you're going up a vertical on a roller coaster and you hear that sort of clicking sound. Even during just the normal printing process, you'll hear that clicking, but it's definitely the most extreme when you're loading in filament or when it's swapping out spools. On top of that, the filament swapping process with this machine is slower than I am used to. Even though it's got 4 Bowden tubes running all the way up to the buffer, it can just add a significant amount of print time to your parts, especially if you've got lots of filament swaps. I'm glad it exists and it can absolutely handle multicolor printing, but I feel like there are plenty of rooms for improvement when they inevitably release a V2. Personally, my preference is to use it for filament management and just maintaining my material. With that, what are my thoughts on the Qidi Max4 based on my time with it so far? From a hardware and build standpoint, Qidi knows how to make large printers, and the Max4 shows how they've taken many of the improvements from past generations and combined them into this machine. The steel frame with the beefy rails and belts gives the motion system the rigidity that it needs. I believe it was the Qidi Plus 3 or 4 years ago that had some issues with the first layer because the Z motors were attached to plastic, which was causing issues with expansion and contraction as the print would go on and the chamber would warm up. Well, they have now taken that and are using a large custom aluminum CNC block to attach to those motors. So that combined with the load cell they're using in the toolhead has been giving me, between this and the Q2, just excellent first layers. The chamber heater and the high temp hot end is great for advanced materials, and the dual auxiliary fan ensures you have no shortage of airflow. Outside of the slightly sketchy screen cable and the better job they could have done with cable management in the back, I don't really have much in the way of hardware or design complaints when it comes to the Max4. Based on comments and some of the feedback I saw online, as well as Qidi's own messages to me, it seems like a lot of the early issues were addressed through some of those firmware updates that happened while I was waiting for a spot to be able to start testing this printer. My biggest wish at this point is that Qidi will spend some more time dialing in better filament profiles. Sure, myself or any users can dial in profiles, and I think that for most, if you want the best results, there will be some tuning involved, but considering the print quality I was getting on the Q2, which yes is smaller, but has certainly some similarities to this printer. The print quality I got, especially on some of the bigger parts, just felt like it was a bit behind. As of right now, personally, I would choose the Q2 over the Max4 because I feel like the overall experience is a bit more polished, but considering the extra complications and considerations that go into making a large format printer, it's not just stretching it in different directions, there's quite a bit that has to go on to make it work. I do feel like the Max4 checks a lot of boxes. And that has been the Qidi Max4. I hope that you enjoyed this video, that you have a better understanding of what it is, what the setup process was like, and sort of what my experience has been like so far. If you have any additional questions, let me know in the comments. And as always, if I don't know the answer to your questions, I have no problem reaching out directly to Qidi to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every other week, so there's always fresh content coming your way. If you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!